Alright, so number 57 is completing the square. So the process is, to make sure, just as a little reminder, if I asked you to square x plus 4 squared, or square x plus 4, then that would be x plus 4 times x plus 4, which is x squared plus 4x plus 4x plus 16, which simplifies down to x squared plus 8x plus 16. So I notice that 4, which is what's inside the square, is half of the middle term, and it's the square root of that, so 4 squared is 16. If I were to then square like x minus 5, then I've got x minus 5 times x minus 5. So I've got x squared minus 5x plus 25, which is x squared minus 10x plus 25. So again, negative 5 is half of the middle term, and then negative 5 squared is the last term, right? So the relationship between these two is the key. That's what we're trying to get to. So that I can rewrite something like this as something like that to easily solve just using a square root. So the first thing you want to do is move the constant over, because that's not part of the perfect square. Okay? Then I take the middle term, negative 8, and cut it in half, and I get negative 4. Now, once I do that, I square that number, negative 4 squared, and I get 16. That is what should be on both sides. So I see that x plus 4 squared was x squared plus 8x plus 16. So when it's a minus 4, which is what we're going to get, a, and then whatever that number is, minus 4 squared, that is this. This whole thing is a minus 4 squared. Negative 8 cut in half is negative 4, and then negative 4 squared is 16. Yeah? And then I'm left with 20 plus 16, which is 36. So the idea is that in order to solve the original problem, I would have to factor or do the quadratic formula or something like that, which sometimes is very easy, but if it's not a perfect thing that you can solve, then or if it doesn't factor, then you would then completing the square would make it a lot easier. Okay? So when I have a minus 4 squared equals 36, in order to get rid of the square, I'm going to square root both sides. And don't forget, when you take the square root, there are two answers, plus and minus. So I'm left with a minus 4 equals plus and minus 6. And then I want to add the 4 over to solve for the variable. So I'm left with a equals 4 plus and minus 6, because I added 4 to both sides. Okay? 4 plus 6 is 10, and 4 minus 6 is negative 2, so in actuality, a equals 10 and negative 2. Okay. Now on, let me see real quick. V squared plus 2v minus 24. Let me see if I can do anything. But so the first thing you want to do is add the 24 over, move the constant over. And then remember, we want to take the middle term, 2, and cut it in half, and I get 1. And then I square that number, and whatever I get is what I add to both sides, so plus 1 and plus 1. And so over here, I'm left with v plus 1 squared, because that's what that equals now. And then over here, I'm left with 25. So I want to take the square root to solve for the variable. So I've got v plus 1 equals plus and minus 5. And then the last thing I want to do is subtract the 1 over. And I'm left with v equals a negative 1 plus and minus 5. Negative 1 plus 5 is 4, and negative 1 minus 5 is negative 6. So I've actually got two answers. Now, just to make sure that you understand, I'm going to make up another problem. If I had x squared minus, let's say, 6x, and then I had plus 11. Yeah. Okay. So, I don't know if this is something you might want to write down or just watch, but I want to show you something real quick. On this one, I would subtract 11, and so get the constant over. So x squared minus 6x equals a negative 11. You take the middle term and cut it in half, so negative 6 cut in half is a negative 3, and then you would square that, and negative 3 squared is 9, so I'm going to add 9 here and add 9 there. So what I'm left with is a negative 2 on this side, and an x minus 3 squared on this side. So as you can tell, on the ones previous, you got 36 was a perfect square and 25 was a perfect square. But it doesn't always have to be a perfect square. In fact, most times it's not. So I'm going to square root both sides, plus and minus. So I'm left with x minus 3 equals plus and minus. There's no square root of 2, so I'm just going to write square root of 2, but that negative comes out as an I. Okay? And then the last thing I do is add the 3 over. And so my final answer is x equals 3 plus and minus the square root of 2i. Okay. Number 64 is solving a radical equation. So in order to get rid of a square root, I have a square root on both sides. I'm going to square both sides. And I'm really just left with the quadratic equation, or no, the linear equation, x equals 21 minus 2x. So I just want to get the same variables on the same side and constants on the other. So I'm going to add 2x, and I'm left with 3x, because that's 1x plus 2x, equals 21. And then we divide by 3, and I get x equals 7. Let's do problem 65. So problem 65 has another radical. So what I need to do is to undo the radical, square both sides, because the radical's by itself. I can go ahead and do that. So I'm going to square this side and square that side. Now on this side I'm left with v squared, but on the right hand side I've just got negative 32 plus 12v. But what you should know by now is that anytime I have a quadratic and a linear and a constant term, I want to get everything on the same side so that I can factor. So I'm going to subtract 12v and I'm going to add 32. So add 32 and subtract 12v. Okay? And the reason why I put it in this order is because so it would be in standard form. Power of 2, power of 1, power of none. Okay. Now I want to factor. The factors of 32 that add up to negative 12. 1 and 32, 2 and 16, 4 and 8, which add up to 12. So if I make them both negative, negative times negative is positive, and they add up to negative 12. So I've got v minus 4 and v minus 8. So my answers are 4 and 8. And I would check them, but we checked them before and they do work. Okay. So, number 73. Number 73 is factored by grouping. So what I want to do is group the first two, group the last two, and I want to set it equal to 0 and solve. Now, what you do not do right now is multiply them out, because that's in no way what we were doing. We were subtracting 30x and adding 12. That doesn't all of a sudden translate to multiplying. So it's called factor by grouping because what I want you to do is factor out whatever's in this group and factor out whatever's in that group that they have in common. So 5 and 2 don't have any in common factors, but x squared is in both. So x squared, and I'm left with a 5 and an x, and a 2, a minus 2, because the x squareds are gone. Now, a negative 30x plus 12, I need a 5x minus 2, so I think what goes into 30 5 times, and that's 6, but I want a positive and negative, and I got a negative and positive, so I'm going to factor out a negative 6. And negative 30 divided by negative 6 is a positive 5, and the x is left over, and 12 divided by negative 6 is negative 2. So remember, the whole goal is to get these the same, yeah? So now I've got this. I factor out the 5x minus 2, and it becomes 5x minus 2 times x squared minus 6, whatever you're left with, x squared minus 6. So then I want to solve each of these. So this right here, I can think of as two different ways. I can either do 5x minus 2, and then I just think, reverse bottoms up, x equals a positive 2/5, or I can just set 5x minus 2 equal to 0 and solve. So add 2, and then divide by 5. Either way, you get x equals 2/5. And for this one, x squared minus 6 equals 0, so add 6 over, and then take the square root. X equals plus or minus the square root of 6. And there we go. Now I'm going to work out 74, and I want you to work it out in your review, but it will not be on the test, okay? I'm not going to ask a question like this. So what I know is that a cubed plus b cubed as a sum of perfect cubes is the same thing as a plus b times a squared minus ab plus b squared. So if I can figure out what a and b are, then I'm good. I've got a cubed plus 27, but 27 is 3 cubed. So b is 3. So I've got a plus 3, so drop the powers. The first one squared, a squared, minus those two times each other, 3a, plus the last one squared, 3 squared, that's 9. And I want to know when this equals 0, right? So the first one is just what makes this 0, and that's negative 3. The other one I'm going to have to do quadratic formula on. So x equals negative b, which is already negative, so positive 3, plus or minus the square root of b squared. Negative 3 squared is 9, minus 4 times a, which is 1, times c, which is 9, all over 2 times a, which is 1. Now if I type in 9 minus 4 times 1 times 9, the inside, right, I get 9 minus 36, that is a negative 27 over 2. Now negative 27 is not as simplified as it can get, the square root of that. So I think that's 9 times 3 with a negative, right? So I've got 3 plus and minus. The square root of 9 is 3. The square root of 3 is still square root of 3. It has a negative, so bring an I out and then divide it by 2. So my answers are negative 3 and 3 plus and minus 3 square roots of 3i over 2. Okay. And then I have, okay, well that's all for this video, and then I'll put all the rest on another video.